Yes, last time we have done necessary condition for local maxima and minima. And in that I told you if the point is local maxima or local minima or it is an extreme point, then at that point f dash c or f dash a must be 0. Now we are coming on the test which will tell you the point which you have taken is a local maxima or local minima. For that, first test we have is first derivative test, and second one which we will be having will be the higher order derivative test. So first we are starting with first derivative test we are going to discuss today. First write down what is this test says. Let f be a differentiable function. On I, some interval is given I, and A is any point belongs to I. A is some element which belongs to I. Then A point I am taking. X is equal to A is the point of local maximum. X is equal to A is the point of local maximum if first condition it says f dash A must be 0. First condition says f dash A has to be 0. And second condition says f dash x changes its sign from positive to negative as crosses through A. So here in this case what it says, f be a differentiable function on interval I, and A is any point we have in the interval, then this point x is equal to A is point of local maxima if what condition hold here, f dash A has to be 0, means at that particular point the slope of tangent has to be 0, and second condition says that f dash x changes its sign from positive to negative as crosses through A. F dash x changes its sign from positive to negative as crosses through A. Now what is the meaning of it? We should make it clear first. This is the function we have, this is x, and here this is a point x is equal to A we have. X is equal to A is the point of local maximum. This is the point of local maximum. Then what is the first condition I told? First condition is that at this particular point when you draw tangent, that will come parallel to x-axis. That means at this stage f dash A is coming 0. First part we got. Second condition is that if you take its left neighborhood, that means somewhere here you take the point, or you take point here, or you take point here, and if you draw the tangents here, anywhere you draw the tangent, then these tangents are making acute angle with x-axis. That means this side we will have theta is coming between 0 and 90. On this left side, theta is always coming between 0 and 90. If theta is coming between 0 and 90, that means tan theta will be positive as it goes in the first quadrant. So anywhere you take on this point, you will find that theta is coming between 0 and 90. That means dy by dx, or I should say the slope, that is tan theta, that come out to be positive as it is in the first quadrant, or I should say f dash x is coming greater than 0. Right? So in this part, what I have here in this case, we should have theta is between 0 and 90. That means we should say tan theta comes out to be positive, or I should say f dash x is also positive. When you go this side and if you draw the tangent, any point you draw, tangent here the slope theta comes out to be between 90 and 180. And if it is coming between 90 and 180 means theta gone in second quadrant, and second quadrant tan theta comes out to be negative. And if tan theta is negative, I should say f dash x is also coming negative. That means here the dy by dx come out to be negative, here it is positive, and here it come out to be 0. So here what you will find that if this is a point of local maximum, first condition I told you that is f dash a has to be 0. Second condition it says that f dash x changes its sign from positive to negative. Its sign changes from positive to negative as it crosses through x is equal to a. जैसे ही आप x is equal to a को क्रॉस करेंगे, आपका dy by dx changes from positive to negative. We will say it is a point of local maximum. So here f be a differentiable function. Differentiable means automatically it will be continuous in the interval. So continuous and differentiable function we are taking. Is some point in the function in the interval, and that point will be called as local maximum. If what condition is there, this should be the point where if you draw the tangent that will come parallel to x-axis. Second condition I told that f dash x which you have should change its sign from positive to negative, which I told you that if you draw the tangent this side, all the tangent will be making acute angle. Here we will be having all the tangent making obtuse angle. So that means this is 0, it changes from positive to negative. So this is a critical point where the dy by dx changes from positive to negative. It is called point of local maximum. Same way when you go for the second part, let f be a differentiable function on I and a belongs to I, then b point. What it says, x is a point of local minimum. If first condition says f dash a has to be 0, no problem in it. Then second changes here, f dash x changes its sign from negative to positive. It changes from negative to positive as crosses through a. As this function crosses through a, we should say function at x is equal to a, the point is said to be local minimum. So here local minimum when you have, that means f dash a has to be 0 and f dash x changes its sign from negative to positive as it crosses through a. Now just check what it takes place here in this case. This is the point we have x is equal to a, where first thing we got is f dash a is 0. Tangent is coming parallel to x-axis. Now if I take the left side first and if I draw the tangent here, then these angles are obtuse angles. or I should say theta is coming between 90 and 180. And if theta is coming between 90 and 180, I should say tan theta comes out to be a negative value. And if tan theta is coming negative, means we should say dy by dx in this part come out to be negative. Here it becomes 0. And at this stage, if you draw the tangents, they all are making acute angles. That means we will say tan theta will be positive here. Tan theta is coming greater than 0, or I should say f dash x is also positive. That means dy by dx changes from negative to positive. So if x is equal to a is the point where f dash a is coming 0, and at the same time your dy by dx changes from negative to positive, we call this point as a local minimum. So x is equal to a is the point of local maximum. अगर आप लेंगे तो f dash a 0 होना चाहिए, and derivative should change its sign from positive to negative. And second one, if it is local minimum, then f dash a has to be 0, and the derivative should change its value from negative to positive. Then we will say it is local minimum. So local maximum, local minimum. Two things we have done. Third case, that is called as point of inflection. Now, what is the meaning of point of inflection? That also you should remember. Now, till now, we have not discussed any point like this. That is point of inflection. What that is, just we should know. If you have the curve like this, on this curve, if I take this is the point, here you will find that this is the point where if you draw the tangent, f dash a comes out to be 0. This is x is equal to 0, or we'll say this is x is equal to a you take. So x is equal to a is this point where you draw the tangent, that come out to be f dash a is 0. F dash a is 0, but here what you are finding, this is a decreasing case. यहाँ भी ये डिक्रीज हो रहा है. इसका मतलब ये अपने नेबरहुड में मैक्सिमम नहीं है. आप इसका नेबरहुड ले लो ये और ये. इस पॉइंट को अगर हम चेक करें तो इधर वाली सारी वैल्यूज इससे बड़ी आएंगी, इधर वाली सारी वैल्यू इससे नेगेटिव आएंगी, छोटी आएंगी. इसका मतलब इट इज नाइदर मैक्सिमम नॉर मिनिमम, बट वन कंडीशन वी गॉट हियर, f dash a is coming 0. So this is the point f dash a is equal to 0, but this is the point which is neither maximum nor minimum. The point where the f dash a is coming 0, or tangent is parallel to x-axis, but it is neither increasing nor decreasing, or we'll say neither local maximum or no local minimum. इस पार्ट पे ना तो लोकल मैक्सिमम है, क्योंकि नेबरहुड में एक साइड में तो ये इंक्रीज करता हुआ नजर आ रहा है, दूसरी साइड ये आपकी सारी वैल्यूज उससे कम आ रही है. इसका मतलब ये अपने नेबरहुड में मैक्सिमम नहीं है, ना ही अपने नेबरहुड में मिनिमम है. आधे पार्ट पे ये मिनिमम है, आधे पार्ट में मैक्सिमम है. इट मींस इन द कंप्लीट नेबरहुड इट इज नाइदर मैक्सिमम नॉर मैक्सिमम नॉर मिनिमम. So whenever this stage comes, we call this point as point of inflection. ये point आपका कहलाएगा point of inflection. Point of inflection. So point of inflection is that point where f dash a is 0, but the function is neither local maximum nor local minimum. And now we will say x is equal to a is the point of inflection. If what condition is there, f dash a is 0, and here we will say f dash x does not change its sign. Does not change its sign as crosses through x is equal to a. When you crosses through x is equal to a, it will not change its sign. Just check here. If you take any point this side on the curve, and if you draw the tangents, always this angle come out to be what? Wherever you draw the tangents here, they all angles are acute angles. And if these angles are acute, because we should take the angle with the positive x-axis, so they are coming acute angle. Acute angle means we will say tan theta is positive. Positive इसका मतलब यहाँ पर जितने भी पार्ट हैं सब पे dy by dx प्लस आ रहा है. On this side, if I draw the tangent here, whenever you draw the tangents here, then again the angles are acute. Whenever the angles are acute, we will say yes, it is still positive. So we should say that dy by dx, either you take left side or right side, whenever it crosses this point, it will never change its sign, it will remain positive to positive, or it can be a negative to negative, that depends. So we will say as f dash x a is coming 0, but f dash x does not change its sign as crosses through x is equal to a, it remain plus to plus or minus to minus, then this point is called as point of inflection. So positive to negative, maximum. Negative to positive, minimum. Does not change, point of inflection. And what is point of inflection? That is the point where f dash a is 0, but function is neither local maximum nor local minimum. That's why I told you f dash a is equal to 0 is the not sufficient condition for local maximum or minimum. This point can be a local maximum, can be a local minimum, can be go for point of inflection. That you should keep in mind. Now coming on.